Okay, so next up we've got Dr. Siouxsie Wiles. So Siouxsie Wiles is my crew biologist who heads up the bioluminescent superbugs lab at the University of Auckland. When the pandemic arrived, she joined forces with spin-off cartoonist Toby Morris to make the science of the pandemic clear and understandable. Their award-winning graphics have been translated into multiple languages and adapted by governments and organizations around the world, including the World Health Organization. Siouxsie was listed by the BBC as one of the 100 influential women of 2020, and in 21 was named the Kiwibank New Zealander of the Year. So we're very privileged to have Siouxsie here with us. Let's take it away, Siouxsie.
Oh.
Siouxsie will be, yes, there she is.
Hey.
Hello, Siouxsie. And of course, the most important thing in your bio is that you are a co-host with me on The Cusp.
Indeed, for many years.
Anyway, I will switch off now and let you do your talk.
Thank you very much. So thank you so much for the invitation to speak at the conference. It's been an absolutely fantastic morning. I've loved every talk. So thank you for hanging around and listening to me. If I click this button, although it does say clicking disabled, I'm hoping that my slides will appear and somebody can talk to me.
All on track.
Okay, I don't know whether the slide I can see is the one that you're supposed to be seeing, though. That's interesting. Can somebody tell me what you can see? Okay, so if I go that way, oh, I don't know what whatever, I can't see anything. So is there a way that you can let me see what the slides are as well? Okay, so I have to do this blind?
Sorry,
okay.
1 minute, we'll see if we can figure this out for you.
So Siouxsie, sorry, are you on the Internet Clicker site?
I'm on the Internet Clicker.
Yeah.
Okay, but this doesn't have the slides in the order that they're supposed to be in. This is weird.
Oh.
Sorry.
Okay.
I can see some slides, but they don't appear to be in the right order. Okay.
Talk to the slide you can see, Siouxsie.
Well, it's not going to help because then everything's in the wrong order, basically.
Okay.
So what we'll do, so why don't we just take, Craig.
Okay, this is it. Now I can see them clicking backwards again.
Yeah, I'm just getting back to the start. Right. Okay, so let's go with that.
Super. All right. So presumably you can now see a title slide, everybody. All right. Super. All right. So yes, I'm Dr. Siouxsie Wiles. I have to start by stating that I am not here on behalf of the University of Auckland. That is just my affiliation where I work. I obviously don't speak for them in any way. And this may well be an activity that they don't approve of me doing. So I'm not sure. Anyway, so I guess I'm going to talk about the fact that I've, during this pandemic, found myself being part of a conspiracy. And actually, it's been great to have that introduction to a little bit of the sort of misinformation that is circulating around. I'm sure most people have seen it. But in order for you to understand how I've ended up in this conspiracy, you kind of have to understand what my journey has been sort of for the last few years. So I'm going to talk a little bit about my research, a little bit about my science communication activities, and then I'll talk about the conspiracy at the end. So I am kind of immensely privileged, I think, to have been able to make a career out of two of my passions. I have several passions, but the two that I want to talk about are this kind of, I guess, a passion for infectious diseases. I have been fascinated by infectious microbes since I was a teenager. And it was really sort of brought about by reading this book called The Fireside Book of Deadly Diseases. I sort of lost in the midst of time how I actually got hold of this book, but I remember reading it and being kind of fascinated and horrified by how, these kind of stories of diseases like tuberculosis and plague. And I do remember at the time thinking, like, gosh, these kind of organisms are amazing, and they get inside of our body and they can cause, so much damage. But not only that, they can kind of change the course of human history. And I always wondered, how would that feel? Now, of course, we kind of know how that feels. But anyway, so that's kind of one of my interests, and I ended up studying microbiology at university. But one of my other passions is bioluminescence. And so this is the ability of living creatures to produce light. And what you can see in the picture are is the light from glowworms. We have glowworms both here in New Zealand and in Australia. And I find this fascinating. Again, there's creatures all around the world that have independently evolved this trait to use this light for all sorts of things. So glowworms use it to attract prey to feed. Others use it for, other creatures use it for camouflage, all sorts of these kind of amazing things. And so what my career is basically been to take the genes that living creatures use to make light and to put them into nasty bacteria and to make them glow in the dark. And so this is what sort of some of our bacteria look like. This is a flask of bacteria. The kind of yellowy color is what they look like in the light. And then when you turn the lights out, they make this amazing light. And it's really, really useful. So they will only glow when they're alive. And that means that we have a really quick way of saying, are they dead or alive? Obviously, the other thing that's really cool about them is that we can measure the amount of light. And basically, the more bacteria there are, the brighter the light will be. So we can, it's kind of like the, I guess, lazy microbiologist way to do microbiology. So instead of having to get these bacterial cultures and get them to grow on petri dishes, which can take many weeks for some organisms, instead we can just take a sample, put it in a machine that emits light, and then say how many bacteria are there. So in my lab, so I run the bioluminescent superbugs lab. It's a kind of team of awesome emerging scientists, established scientists who are kind of working with me to try and basically do all sorts of cool stuff, all involving glowing bacteria. So one of the major projects we have in my lab is looking for new antibiotics. So actually, we're right now in the middle of World Antimicrobial Awareness Week. If you weren't aware, we are kind of globally running out of effective antibiotics and other drugs into antifungals. And this is really bad news. It's become especially bad news in COVID, but it means that for some diseases, we're actually running out of really effective antibiotics to treat infections. And so in my lab, we're trying to find new ones, or at least new compounds that will kind of, potentially form the basis of new drugs. And the way we're doing that is we are searching a collection of fungi that exists here in New Zealand. So Manaki Whenua are one of our Crown Research Institutes, and they have basically got this collection of fungi that has been collected over the last sort of 50 or 60 years. And the reason that we are interested in looking at fungi is because penicillin, which is one of the very first antibiotics ever discovered, comes from a fungus called Penicillium. And so with New Zealand having, lots of plants and animals and fungi that are found nowhere else in the world, we hypothesized that this collection may well have, new chemicals that might make good antibiotics. So the way the project works is that we have our collaborator at Manaki Whenua, who's Bevan Weir. So he basically looks after this collection. They get these fungi out of liquid nitrogen for us. They come to our lab. We basically pit those fungi against our glowing bacteria, looking for ones where the lights go out. And then if the lights go out, we will grow up large amounts of that fungus, and we will basically give it to our chemistry collaborators, Brent Kopp and Melissa Kadalis, to look for what chemical compounds are there. And the hope is that we don't just discover penicillin over and over again. And actually, we've discovered very little penicillin. We've got all sorts of other things. But I just want to show you what this kind of looks like. So this is actually, we've kind of massively changed our assays now, kind of miniaturized everything. But this is sort of what it looks like on a large scale, which is that we grow these fungi on either liquid or solid media. If we're growing them on solid media, we will then basically chop out little holes, fill these holes with our glowing bacteria, and then we just look for light. And we're asking whether the light stays or goes. And so if we do lots of different species of bacteria, and so we can say really quickly, is this fungi producing something that's killing all our different bacteria, or is it just killing one or two different types? And then from that, we can kind of go on to see if we can find any, what are the compounds that are doing the killing. The other thing that's really cool about light is it travels through flesh and skin. So if you put your hand over the top of a torch, you'll see light coming out the other side. And so this has been a really actually amazing use of bioluminescence in science. So in microbiology, we use these tagged glowing bacteria to study how they cause disease inside of animals. So this is just a picture of a sleeping mouse with a bacteria that we've made glow that causes a sort of form of food poisoning. And we can visualize where the bacteria are inside of that living animal. And so you can see it all there in its gut. And we also, so this is, as I said, it's food poisoning. This is a bacteria that goes in one end and comes out the other. And so we can see it coming out the other end. And the other part of the picture that you can see is basically glowing mouse poop. And so this, this project actually in my lab has been about trying to understand how bacteria change, as they evolve, I guess. So many years ago, we started this experiment where we take this mouse that's infected, and we just add another mouse to the cage. We allow those mice to interact. The one mouse will spread the infection to the other mouse, and then at each stage, so we do this over and over and over again. At each stage, we take the bacteria and we store them, and then we kind of come back to them later and say, how have they evolved over these different transmission chains? And what we found a few years ago, actually, is that in 8 out of 10 of our experiments, the bacteria become more infectious. And so we've been trying to figure out ever since what are the changes that have been made that make them more infectious. And so it's kind of been interesting, but also, so I guess intellectually interesting while also horrifying to watch how COVID-19 and the variants have arisen and changed as the pandemic has gone on, because this is exactly what it would have been predicted by our experiments. The other thing I'll say about this is that it's a technique. So while this is how we're using it in microbiology, people have tagged cancer cells, people have tagged all sorts of things to be able to track where they are, either in in living animals or in cell culture, all of these kinds of things. So it's a massively widely used technique in science that really gives us really interesting information, because we have this sort of really visual thing. Where is the thing that you're looking for, and you find it by looking for light. Okay, so one of the things, though, about me is that I really firmly believe that research doesn't end with a peer-reviewed publication. And so on a personal note, also kind of being publicly funded, it's been really, really important to me to learn how to communicate in different ways to be able to talk about our research. So I've done this in lots of different ways, but for me, the journey started with blogging. So I used to do a blog on the Science Media Centre's site here called SciBlog. So my blog was called Infectious Thoughts. And I just sort of wrote about outbreaks that were happening, interesting microbiology stories that I had read. And what I was trying to do was learn how to write less academically, I guess. And it was through that blog that I ended up being asked to comment in the media in New Zealand about microbiology stories. So the first one that I did was an interview, I think it was about 2010, with Mike Hosking, of all people. People in New Zealand will know that name, talking about an outbreak of E. coli food poisoning in Germany. But since then, I've done that many times. So I kind of think of myself as a sort of scientist communicator, but I've become somebody who's known by journalists who's able to talk to them about microbiology stories. So when the Ebola outbreak happened, when the Zika virus outbreak happened, when we had the Fonterra botulism scare, these are all times when journalists call me up and say, tell us about this microbiology story. So I've done lots of other things as well. I ended up winning some prizes, and one of those prizes actually came with a considerable sum of money to spend on a science communication activity. And what I ended up spending it on was making a little web series with my daughter, Eve, about microbiology aimed at children. And it was so fun. It was kind of a long project, which you would never know given that there were only 4 episodes of it. It's quite expensive to make this sort of stuff. But we did things like swabbed our belly buttons and our toes looking for bacteria, and then went off and made teas with them, all sorts of things like that. So I was trying to show, about microbiology in food. We did one episode about the microbiome, and then we did an episode also about the bacteria that glow in nature. So the sea is absolutely full of glowing bacteria. They are there for all sorts of reasons, and we basically isolated some of this bacteria and then ended up using it for an art exhibition, which I shall talk about in a moment. What else have I done? Okay, so the art exhibition. So many years ago, I was really interested in starting to put science in places that people weren't expecting it. And so because there are these bacteria that naturally glow, they're completely harmless. I basically got a fish from the supermarket and stuck a Q-tip up its bottom, and then basically placed it out and isolated this glowing bacteria. And ended up collaborating with various artists to do different art exhibitions in different places. So in New Zealand, in Auckland a few years ago, we used to have this exhibition called Art in the Dark. So it was kind of set over the evening. It was all about artworks that glowed. Pretty much all of them were powered by electricity. But an artist contacted me when they found out that I was somebody who worked with glowing bacteria, saying, would I want to work with them? And it just so happened that I had this glowing bacteria and was kind of ready to do something. And so we ended up, her name is Rebecca Klee, and we ended up doing this collaboration together where we got some squid 3D printed, and then we basically filled them with this glowing bacteria. And this is because there is a bacteria that lives in the sea that forms a symbiosis with a squid, the Hawaiian bobtail squid, and basically the squid uses this bacteria as a form of camouflage while it's hunting at night. And so this led on to lots of other kind of science art sort of collaborations. One of the most fun has been doing what we call Petri dish art. So this is giving people Petri dishes and this little solution of the bacteria and a little Q-tip, and then getting them to draw a design on the Petri dish using the bacterial solution. So it's a bit like drawing on jelly with invisible ink, because you can't actually see what you're doing. But wherever you put the bacteria, overnight they will grow, and wherever they grow is where they will glow. So we've done lots of art exhibitions like this, or gone into schools and done things. But I've also done quite one big art exhibition for the Auckland Arts Festival in collaboration with Think Science. And this was actually to give these Petri dishes, much larger Petri dishes this time, 25 centimeters by 25 centimeters, and giving these to artists and then getting them to do kind of artworks, living artworks, basically. So this here is a photograph of the works of a graffiti artist called Cinza. So each of those squares that you can see is 25 centimeters by 25 centimeters, and so he did this big drawing of a viperfish, and so that all the drawing that you can see there is basically from the light that these bacteria are emitting. And I've done exhibitions like this all over the world. I've done them in the US, done them in Australia, and so we actually have a kind of website full of pictures that people have drawn, emojis and all sorts of things that people have drawn in glowing bacteria. What's next? Oh, and if you're interested with Christmas coming up, one of the things that we've done actually from all of these exhibitions has been taken photos of them and put them up on a site called Redbubble, so you can get kind of t-shirts and various things, and all the money generated from this, there's not much, but it goes to fund my lab's research. So just a note, the only plug you'll get. Okay, so then the pandemic arrived. So I guess what I'm leading up to this is, so I'm an expert in infectious diseases, but I've had this sort of 10 years of learning how to communicate about science in lots of different areas, including in the media. So I've become, already before the pandemic was kind of a go-to person for many members of the media. And so when the pandemic arrived, for me, it just started like any microbiology story did, was that in mid-January last year, my phone started ringing and journalists started asking me to explain what was going on. And of course, at the time, we didn't know very much. So my first couple of interviews are like, well, there's a pneumonia in China. We don't really know very much at the moment. Watch and see. And then obviously a few weeks later, it was like, holy moly, this is moving rather fast. And here we are nearly 2 years later. So as I say, for me, it sort of started in the usual way, which is just to start answering my phone, do radio interviews and TV interviews. But what I hate about these kinds of formats is that obviously you have a very short period of time. You're asked for a soundbite, and you can't really say everything that is your thinking, or point to all of the evidence that's helping you inform your thinking. So I ended up being asked by the Spin-Off, which is a little media organization here in New Zealand, to write, if I wanted to write anything, I could write it for them. And so I started writing for them in late January last year. And it was really just trying to really just keep everybody informed with how things were changing. Again, point to where I was getting my evidence from and explaining to people what I thought it meant, while also trying to put things out there to help people understand how we might need to behave. So I did on posts like, how to prepare, which is about, having a pandemic preparedness plan, talking to children about the pandemic, all these kinds of things. And then in late February, very late February last year, I saw this tweet, which was this concept of flatten the curve. And so because I was writing for the Spin-Off, I wanted to write about this concept, but I thought this graphic didn't really do a good job of explaining really well what this concept was. And so having worked with artists and illustrators in the past, I immediately asked my editor at the Spin-Off, Toby Manhire, whether he thought Toby Morris, who is a cartoonist who works for the Spin-Off, would be interested in working with me on this. So Toby is somebody who I didn't know at the time, but have long admired his work. So he, say, is a cartoonist, and he does really interesting cartoons that are about really important issues. So he covers things around inequality and poverty. And I just thought he would be, I just thought this would be amazing if he would do something. I wonder whether he would. And so within an hour, Toby and I were on the phone, and I had sent him the tweet, and we were talking through ideas, and I was like, it'd be really cool if we could have this GIF that kind of toggled between these two realities to show people how our actions will help this concept of flatten the curve. And so we made our graphic. Many people around the world saw this graphic. It went absolutely doolally. Like, we put it out on Twitter, and then it just got like millions of things. It just went absolutely mad. This is just a thing from the HuffPost that talked about it, and it even ended up, to our surprise, being held up by the Prime Minister to sort of talk about why we were going to respond the way we ended up responding here in New Zealand. It kind of started this amazing collaboration. So Toby was like, right, what next? So we've done lots and lots of graphics now. But the next one of ours that went viral in a quite different way, I guess, to the flatten the curve, was sort of in March last year. And it was trying to explain exponential spread. So showing how, one case becomes many over a few generations, but also trying to show that by our actions, we could stop being part of a transmission chain. And I guess the graphic, as we look at it now, reflects where we were in New Zealand last year, and I guess Australia would have been the same. We were talking about not going to that barbecue, and not flying or working from home and everything like that. Now we have a new version that's kind of like wear a mask, get vaccinated. But that was sort of where we were at. The other thing I didn't mention is that when we released our first graphic, and every graphic since then, we released them under a Creative Commons share-alike license. And so for us, it was really important to really say that you can, anybody who wants to use these can adapt them. Please adapt them. And so, we saw that immediately happen with our first one. So when we did Flatten the Curve, it ended up immediately being translated in lots of different languages. There actually ended up being a guy who made a program that every time we had a new graphic come out, he would sort of load it to this program, and you just had to say what language you wanted, and then it would automatically translate it. So that was kind of amazing. But yeah, they ended up being adapted a lot, and this one ended up being adapted by various organizations and governments. So there's a version there by the Australian government, there's one by the German government, there's India used it as it was. There's a picture there of it in German on a German bus stop. So it went absolutely kind of everywhere and was used, which is really amazing. So yeah, so that kind of, I guess, started what has been the most incredible, productive collaboration of my entire working life. You know, we have now probably over 50 graphics that go from everything to explaining the science behind genomic sequencing and mutations and variants. We've done things around, you know, the vaccine, all of these kinds of things as we've tried to explain, you know, through this kind of medium of these cartoons. And what we really were wanting to do was sort of make this information, you know, shareable, accessible to everyone. And it was amazing when the World Health Organization basically got in touch with the spin-off to say, people keep sending us your graphics. And so what ended up happening was the spin-off and Toby were basically contracted by the WHO to do some of their communications. So it was amazing to see, you know, our graphics that we would sort of try out here in New Zealand, and we'd, you know, Toby and I would sort of workshop them together. We'd release them, and then he would pitch them to the WHO, and then we'd see them adapted for a more global audience. It's kind of amazing to see that. So to see them end up having these kind of millions and millions of views has been amazing. It was also really cool. So in those, when they first got their contract, I was kind of like a consultant, I guess, and so I was sort of thinking, what do people need to know, what might they, you know, what might people need to understand in the coming months, and then Toby and I would sort of work on those ideas in order to then pitch them for the WHO. So yeah, so that's me. So that's kind of me as a researcher and me as a communicator during this pandemic. So this is where we kind of get to the conspiracy. Which I first became aware of, I guess, through social media. And it kind of came with these sort of tweets that started to talk about Bill Gates and this conspiracy that existed, that basically Bill Gates was working on a vaccine that was going to microchip everybody. And that this conspiracy became known as luciferase, but at the time it was basically that they were putting luciferase, I guess, into the vaccine or something. I don't know. It's all a bit confusing. But essentially, the word luciferase became associated with Bill Gates and the vaccine. So this I don't know where it originated from, but this was it being reported in Natural News, and so people started to associate me then with this work, and one of the reasons that they associated me with it is because before I moved to Auckland, I was at Imperial College in London, and I was working on a Bill and Melinda Gates Foundation funded project to make the tuberculosis bacterium glow in the dark in order to speed up drug discovery for tuberculosis. And so here's a picture of our glowing TB inside of mice. These are the same mice at the start of basically being treated with antibiotics, and then you can see them. You can see the lights disappearing as the treatment works. And so I guess what I didn't talk about when I started was that. So bioluminescence, this chemical reaction made by creatures that make light, there are two key parts to this chemical reaction. So the first is an enzyme called luciferase, and this enzyme luciferase acts on a substrate called luciferin and basically produces light as a byproduct. And so, as I said, you know, we use this to track bacteria, but other people have used this to track all sorts of things. And I wonder whether this conspiracy sort of started by somebody trawling through the Bill and Melinda Gates Foundation's funded research. So they fund a huge amount of biomedical research. And they also have what's called the explorations grants, which are really small grants that they can go to anybody. You don't have to be affiliated with an organization. You just have to have a good idea. And so they funded huge amounts of stuff in the past. And I wonder whether somebody had gone through that list and found something that was funded by Gates Explorations to do with luciferase. I mean, they've certainly found our research, but other things, maybe to do with trying to track parts of vaccines, or I don't know. Anyway, but somebody has put 2 and 2 together and come up with something that doesn't equal 2. But then because of because it's Bill Gates, because of his the Gates Foundation also support work to encourage women to use contraception and all of these kinds of things. That's led to this idea that there's sort of a global agenda to control populations. Anyway, it's just become this big mess, but part of a big mess, which they've now named luciferase. And so I found myself, getting all these wacky emails and messages from people who basically believe that I am funded by Bill Gates as part of his conspiracy to depopulate the world. And I don't really know where to go with that. One of the other parts of my story that I didn't talk about is that when I started doing science communication, especially when I started working with artists and illustrators, what I was doing was applying for science communication grants from like little societies and things, so that I could pay those people for their labor. So for example, I did a whole bunch of little animations with a lovely guy in Australia whose name some of you might recognize, actually, Luke Harris. And we made these little animations that were about creatures that glowed and then uses of light in science. And the first one that we did, it took ages to get Luke paid, because of course he wasn't somebody, who traditionally had worked he hadn't worked at the university. And so getting this whole university finance system to pay him drove me insane. So I decided to start a little company that meant that I could potentially apply for grants and stuff, that I had a way of kind of of being able to pay people easily if the university were going to be such a pain about it. And I'm very bad with names and things. So I sat with my lab group one day and I said, I need to come up with a name for something for this company. What should I call it? And I think it was my postdoc, Jimmy, at the time, said, how about you call it Luciferin Limited, as in a play on word of luciferin. And so I was like, that is genius. So I started this little company called Luciferin, which has done absolutely nothing. It's just, I love the name, so I haven't shut the company down. So it still has this kind of company name. And what I ended up finding out was that somebody had, there's a company that kind of collects, I guess they collect records of companies or something, and then they sell them to people, maybe for marketing purposes. But somebody had made on this website, this company in the USA or something, it said that Luciferin Limited was a testing company that had kind of revenue of $1 million or so, and was had several employees and things. So somebody had basically made up what my company was, which you can see from the company's house, register, what it is that it does. It's involved in education, but it said it was basically a testing thing. And so now people started to associate me with getting money for doing COVID testing. And I ended up getting phone calls from people demanding, how could they get a COVID test and what would I charge and everything. So there's been this whole kind of weird thing. Anyway, so that sort of has all kind of happened. Then people started to find the pictures on the internet of us doing our art displays, and so they now became these New World Order symbols that we were doing things. And then because of the luciferin and because of luciferin, suddenly now I was a pinkhead witch and Satanist. So that's been the other thing that lots of people have been saying about me. And it's kind of interesting, right? Because I don't really know where this comes from, but obviously there's Lucifer, the word, that's used in some places to refer to Satan. There's obviously luciferase and luciferin, which were which were phrases that were coined by this French man in the 1800s to refer to these enzymes and substrates, because so he studied bioluminescence. And the origin of all these words is basically from the Latin word for Venus, which is morning star or light bringer. And so it's kind of interesting how all of these things have got sort of melded together and become this, to say, incredible conspiracy. But the people who've really, really run with it here in New Zealand are Vinnie Eastwood and Billy Te Kahika. So they've become quite obsessed. People have sent me footage of him talking about me as, you know, that he calls me Billy TK. Seems to think I've got purple hair, so he often refers to me as the purple head, which I don't know whether purple is maybe a more satanic color than pink, but anyway. So he's done, you know, videos ad nauseum about them. People have sent me footage that he's released of speaking at meetings about me, and he always refers to me as a Satanist. So I am just one of these evil people. I ended up writing an article about why I had this company Luciferin and explaining its name to being about luciferin, and they used that as another one of their pieces. It's like, look, she's being so blatant. She's saying she's a Luciferian. She's a Satanist over and over and over again. So yeah, so it seems like you can't even, you know, explain what these things mean. But the number of emails I get on a fairly regular basis or messages on Facebook, are you really a Satanist? I'm like, no, I'm an atheist. Anyway, so yes, that's how I've ended up being kind of caught in this conspiracy. And I guess I never would have thought that my love of glowworms and fireflies would have seen me labeled as, you know, an enemy of the state. And a Satanist in the global pandemic. But there you go. So with that, I will stop. And then if there are questions, we can do questions. Otherwise, we can have an early lunch break. Thank you so much for your attention.
Thanks, Siouxsie. That was a fantastic talk, and you're obviously a fantastic science communicator, and your talks are always fascinating. We've got a few questions here. So Clinton Lovell says, can this great work with bacteria also be used for viruses? And I think at the time he was referring to putting the bacteria on the petri dishes and having them glow. So I wonder whether there's any applicability to viruses in that context.
Yeah, so people have engineered the viruses in the same way, and not every virus can be engineered. They don't use the same system that we use. So we use this, as I said, bioluminescence has evolved lots of different times, and so there's a whole bunch of different kind of chemical reactions, I guess, that make it. And there are subsequent genes. So we use particular ones actually for the TB work. A lot of that work we used the firefly bioluminescence reaction, and that's one where you can just engineer the gene into a particular organism, and then you add the substrate called luciferin. And so that is the one that has actually been used in viruses. So there are viruses that have been engineered with this luciferase gene, firefly luciferase gene, and then if you add, so you can infect animals, and then you can feed them luciferin, and then wherever the virus is, that it will glow. So this has definitely been done, but it's not useful. Like, people have asked me all the time, you know, this would be really useful because you could kind of see it coming, right? It doesn't quite work that way. We wouldn't actually see, you know, they emit very, very small amounts of light. There are much easier ways to kind of do this. And I guess this is what, if we go back to what the conspiracy is in terms of, you know, tagging the vaccine, right? I think it may well have come because the Gates Explorations grants have, I think, funded some applications that are about how, you know, when you've got people who are transient or have no, you know, there's no health records, how can you ensure that you know whether, you know, somebody has, you know, been vaccinated or something? And so I think maybe there was a project that said, well, we could do something with a tag, right, so that you could essentially see whether somebody had received something. I mean, it's obviously not happened. But so then maybe this is where the luciferase idea came from. But the point is that there are way easier ways to do this. And luciferase is not in any way the easiest, actually, because you'd have to, only living cells glow. So it's actually completely impractical. What you do is essentially, you just mark somebody with with some kind of fluorescent tattoo and then you just have to put a black light over it and you could see it. So it's sort of interesting how how this sort of all got kind of mixed in together. But yes, it has been used, at least for biomedical research, on vaccines as well.
I loved when you tried to explain the conspiracy theory and how difficult it was for you to actually make it sound coherent.
It really is. And I guess it also changes, depending on who's saying it. They've got a slightly different aspect of it, so it's hard to keep up.
Yes, okay. So we've got one more question here. This from Linda Talberg. I hope I'm pronouncing that correctly. The microbiome seems to be a hot topic, and there is a lot of interest in the wellness community. How much of this is hype and how much of it is science-based?
Oh, great question. So it's really hard, right? And there are really genuine, efforts to try and figure this stuff out. There's what we're understanding now about the microbiome is it's so important for our health in general. So important for, it's even important. There's been some amazing studies showing how important it is for development of the brain during development of a fetus, right? There's been experiments done in mice that show that if you remove the mum's microbiome, you impact the development of the growing brain. So it's clearly important. But whether we will ever have products that actually do what the people claim they will do, it's really, really hard to say. So that doesn't stop companies from trying, and it doesn't stop companies and people from making claims. But from what I can see at the moment, there is very little evidence for any of that kind of stuff. And actually, the way the microbiome might end up being more important is how it impacts us as individuals. And so one of the studies I remember reading about and being kind of blown away by was a study about Parkinson's disease. And so it's all about you treat Parkinson's disease with basically giving people dopamine and various things. And depending on what microbiome guts they had, treatments were either successful or not, because these bacteria in their guts have enzymes that can basically either destroy the treatment or can make the treatment toxic. And so actually what might be important for the microbiome is understanding on an individual level what gut bugs you have, so that we know whether a medicine will work for you or not, and whether you might need some, it being to be treated in another way. But we're a long way away from being able to say, here, have some of these bugs, and then you'll be well. There's two things that we know it works really well for, and one of those is fecal transplants to treat a particular horrible diarrheal disease in kind of hospital patients, and then also in treating diarrhea in babies in countries like India. So all the other stuff is probably bullshit.
Very early days.
Yeah.
Okay, well, thank you very much for your talk, Siouxsie. It's fantastic, and we're having you back again this afternoon on the panel.